Hello and welcome to Easy Maths. In this particular lesson, I'm going to take you through the solution by completing square, and shall look at the other objectives later. And as always, please like, share, and subscribe. I'll particularly like your comments regarding my lessons. Maybe I'll know how to present better. Let's focus now on a solution by completing square. As we begin this part, let me say the following. The first thing, solution by completing square normally involves completing a square of two terms before the equal sign of a quadratic equation. The completing square in this case means coming up with a perfect square. This might not be as clear now, but I'm going to explain that in actual examples. Now, we normally use this formula when you're looking for solutions for questions which cannot be solved by factorization. And so we usually use this method for that particular reason. Now, let's look at examples maybe to tie this together. The first thing, we're given a question there, x squared plus 6x plus 3 is equal to 0. Now, the first step there is to separate the first and second terms from the third. You see, we have three terms. This, the next one, we need to have the first two together and the third one goes on the other side of the equal sign, that particular way. The next thing is we use the first two terms to make a perfect square. What I mean is the x squared plus 6x, we add a third term so that we have this term as the first one, this as the second one, and that third term, such that the three of them make a perfect square expression. And obviously, since we have added a term here, we're also going to add it after the negative 3, and therefore we have it this particular way. I've just put that term as c, and since I added it before the equal sign, I've also added after the equal sign. Now this is the question here. If x squared plus 6x plus c is a perfect square, then what is the value of c? Now normally c is the square of half of the middle term. In our case it's 6, so the coefficient of the middle term is 6. 6 divided by 2 squared gives us the value of c. In our case it's 9. So we can say to make a perfect square using x squared plus 6x, we would need a third term which would be 9, such that this expression here is a perfect square which can be factorized to form a perfect square expression, or two brackets that are multiplied together. Now, having added 9 before the equal sign, we also added after the equal sign. Now let's move on also this way. Factorizing this part here gives us x plus 3 squared. The reason is we have square root of this, which gives us x, the sign of the middle term, which is positive, and then square root of 9, which is 3, is equals to minus 3 plus 6 plus 9 is just a positive 6. Now at this point we're going to simplify by taking square root of both sides so that we eliminate the square here, so that you're now going to have x plus 3 is equals to the square root of 6. Now it should be remembered that the square root of a number in mathematics is normally positive or negative, so square root of 6 is actually a positive number or a negative number, and in our case it is a positive 2.45 or the negative is the same. So this is the reason why normally quadratic equations have two answers. There's one answer which is normally generated by the fact that this square root is a positive. There's another one generated by the fact that this square root is a negative number, or could be a negative number. Now considering the positive one, this one here, we can take the 3 the other side so that we have it this particular way, and therefore the value of x will be negative 0.55. Or considering the negative one here, we can take the 3 the other side so that have it appear this way, which gives us an answer of negative 5.45, and therefore the values of x here are those two there. Now I've taken you through that operation there in a very detailed way. So as we look at other questions which are just like this, we're not necessarily going to go through every step there, but I hope this explains every part of that you should understand about how to use the completed square method to operate questions. So let's look at some others. We have this other one here. So the first step, we take 5 the other side so that we have two terms which are going to use to make a perfect square. So using the x squared minus 3x, we add another term. That term should be square of half of the minus 3, which is this one here. I have put a negative here, and it's also negative here. The whole reason I put this negative here so that it reminds me to have, when I'll factorize it at the end at some point, it should look like this, and this negative here will remind me that I should have a negative here. So just let it remain there. Now the next step is we factorize before the equal sign the expression. So factorizing this one here is just get the square root of x squared, which is x, get the sign of the middle term, which is negative, and it's also this negative here, that one there, and then get the square root of 3 over 2 squared. So just 3 over 2. Again, simplifying this part, we get 7.25. Now we'll now take square root of both sides to eliminate the square here, which gives us this sort of a thing, the square root of 7.25. Now the square root of 7.25 could be plus 2.69 or negative of the same. Now the value of x therefore will be either x is 2.69, this is positive, adding 2.5 adding 3 over 2, because when this goes the other side it becomes positive, which gives us 4.19, or the value of x could be this negative 2.69. You now also add this one, 3 over 2, which gives us negative 1.19, and therefore we have two answers for this using the quadratic formula, sorry, the completed square method. Now we move on to another example. We're given this question that's before us there. Again, let's make a perfect square. First of all, taking the that term the other side, so we have x squared minus 8x is equals to negative 13. We use x squared minus 8x to get to make a perfect square. So adding the third term, it will be minus 4 squared. The reason is we just had negative 8 divided by 2, which is negative 4, and then we square that so that we get it this particular way. Since we've added a term before the equal sign, we also add the same term after the equal sign, and simplify appropriately. Again, factorizing the expression before the equal sign, you're going to get the square root of the x squared, which is just x, the sign of the middle term, which is negative, and it's also this negative here, and also the square root of 4 squared, which is just 4. And so we have it that particular way. Now 13 minus 13, that is minus 13 plus in brackets minus 4 squared should be 3, and so we have it that particular way. Now we're going to take the square root of both sides so that we eliminate the square of x minus 4, so we have it that particular way, and so we now get the square root of 3. Now obviously the square root of 3 can be positive or negative 1.73. So the first case, the square root of 3 being 1.73 positive, we could write the expression that way, or we could write it this other way when it's now being negative, and now continue to operate until you get the value of x. Considering the first case here, we can take the 4 the other side so that you get x is 1.73 plus 4, which is 5.73, or considering the other case, we could write it x is equals to minus 1.73 plus 4, which is again x is 2.27, and there we have two answers for the equation that were given using the completing square method. We move on to the second last question. We have an interesting one this time. The coefficient of the first term is not 1 like it has been in the previous questions. So now this one is operated a little differently, but not very different like from the others. So this is what we do. The first thing, take the negative 9 the other side so that it becomes positive. Divide everything with 4. So the 4x squared divided by 4 would just be x squared. Now we have made it to be exactly like the other questions were. The coefficient of the first term is now 1. 12x divided by 4 gives us 3x, and of course we said 9 is divided by 4, which gives us this, and it's crossed the equal signs, that is just a positive 9 over 4. So after this point, we just progress as we've done in previous cases. We now come up with a perfect square using the first two terms as x squared. The second term is 3x, so we get a third term, and the third term will be 3 over 2 squared. How? It is square of half of the coefficient of the middle term, so we have 3 divided by 2 squared. That gives us that term there. We also add it after the equal sign so that we don't change anything about the equation that was given. At this point, we are going to factorize the expression before the equal sign, because now it's a perfect square. The factorization will be easy. Get the square root of x squared, which is x. Get the sign of middle term, which is positive. Get the square root of 3 over 2 squared, which is 3 over 2. So there it is, and of course you square everything there. After the equal sign, you simplify that, you're going to get 18 over 4. Now at this point we take square root of both sides. We're going to get x plus 3 over 2 squared. Square root of that will be just as it is. Then we take the square root of this. Now we progress as follows. The square root of 18 over 4 is either positive 2.12 or negative 2.12. The degree over 2 is just 1.5. So this expression here can be written as x plus 1.5 is equals to that, or x plus 1.5 is equals to the same but negative. Now we move on. Using the first case here, take the 1.5 the other side, it becomes negative, and simplifying that gives us x is 0.62, or using the other case, x is equals to negative 1.5. When it has crossed the other side, you subtract 2.12, the answer becomes negative 3.62. And there we have two answers for the value of x. We move on to the very last question, and this one is interesting since it's involving some fractions. The first thing, of course, you take the third, the other side, so that becomes a positive. You use the first two terms here to come up with a perfect square. And now that we are having a fraction, please understand that the third term, this is the first term, this is the second term. The third term will be half of half squared. Half of half squared means 1 over 2 times another 1 over 2. 1 over 2 times 1 over 2 is the same as 1 over 2, but the 2 below the division line being multiplied by another 2, and therefore we're going to write it this particular way. So it's 1 all over 2, but that 2 is multiplied by another one, so that we are getting half times half, or rather half of half, then squared. That same term is added after the equal sign, like this. And I've simplified it for you so that I get negative a quarter squared, and again negative a quarter squared there. Everything else is just done same way we've been doing in previous questions. Now we're going to factorize the expression before the equal sign, because at this point it's a perfect square. And so when this one's factorized, it's going to be x minus 1 over 4. The x is the square root of this x squared. The minus is the sign of the middle term. That's minus 1 over 2, which is also the sign of this one here. And then a quarter is the square root of 1 over 4 squared. And so we have it there. All of it squared. Simplifying after the equal sign, you get 19 all over 48. And this is what you have after you take square root of both sides, with the intention of eliminating the square of x minus a quarter. Now, the square root of 19 over 48 can be positive 0.63 or negative or the same. So using the first case here, we're going to have x is negative a quarter. Going to the other side, it becomes positive. Then you add 0.63, which gives us 0.88, or using the other case, we have x is equals to the quarter going to the other side becomes positive, and we subtract 0.63, which gives us negative 0.38. And therefore, we have now finished that part there about the concept of solution of quadratic equation using the completing square method. I want to test you here. Therefore, we have some two questions. This one here, it's not arranged in the standard order, so you need to arrange it. The 3x squared should be the first one, followed by this, and followed by 4. There's another question there. Please check out for the next lesson that will be posted, I think, the same time with this particular one. Thank you.